thing from this one, other than the fact that you should be through that number 5 by now on page 2 of your green packet, we will be opening a online formative this afternoon. It is on It's Learning. It will automatically dump then into your grade book, or into my grade book on Infinite Campus. You have to get it done by 11:59 p.m. Sunday night. Okay? You get 3 attempts. It's not, you just go back and fix the one that you got wrong or something like that. You have to retake the entire thing. You get 3 attempts at it. The best of the 3 attempts is what gets entered into the grade book. Okay? All right? So that needs to be done by Sunday night, 11:59 p.m. After that, it just goes in as a 0. Okay? And this is one that you can't fix afterwards. Okay? This is one that you have to do online, and once it's closed, it's closed. We won't reopen it for you. Okay? All right? So you've got from this afternoon until Sunday night to get it done. Okay? 3 attempts at most. Okay? If you get a perfect score, and it'll tell you what your score is out of it. If you get a perfect score, you don't have to go on to your second or third attempts. Or if you get in your second attempt, you get a perfect score. You're good then. Okay? Right? If you want to go on, hey, try it a third time. Not going to stop you. Okay? So there are the answers to number 5 again. Okay? All right? So today then we're going to start talking about the quantities of a vector. Okay? A vector has 2 quantities. The first quantity is it has a magnitude. Okay? The magnitude of a vector is the length of that vector. Okay. If you remember from the Despicable Me clip that you should have watched yesterday after you're got done with you doing the word problems, okay? A vector has both direction and magnitude. Okay? Magnitude then is the distance, okay, the length that vector is going. Its symbol is a double absolute value. Okay? That is the symbol for it. Okay? Since vectors in the standard position all start at the origin, okay? The tail is at the origin, the head then is somewhere else, so this particular vector here would be out there, 2 over, and 3 up, okay? But the tail is at the origin, so the distance formula, where we subtract the x's and subtract the y's, if we're thinking about it in terms of points, the distance formula, because that's going to be the magnitude then, is just, all I have to do is take the square root of the first part, the horizontal component squared, plus the vertical component squared. Okay. So I simply just square those and take the square root. Negative 2 squared is going to be 4. 3 squared is going to be 9. 4 plus 9 is the square root of 13. So the magnitude of W is the square root of 13. Again, that's using the distance formula with one of the points being at the origin. Okay. Vectors also have a direction angle, and that direction angle is a unit circle angle. Where 0 is straight to the right, and we go counterclockwise. Now, because we're dealing with vectors could be anywhere in the 360 degrees around the origin, we are going to use reference angles. Okay. So we're going to use our reference angles. So if I go back to vector W, where vector W was up here, 2 over 3 up, 2 to the left and 3 up, okay? I am going to actually find this angle in, I should have drawn it bigger. Now, let's see if I can do this now. Let me group it, and then, oh yeah, there we go. Now we're talking. Look at that. I can do tricks with technology, okay? I am actually going to be finding this angle in here as my theta prime, because that's the reference angle. It comes off of the horizontal. Okay? I know that in this triangle that this is 2 and this is 3. Notice what I did there. I dropped the negative to make it so that I have a positive triangle, because I want to be in quadrant number 1. I want to find the acute reference angle. Okay? So that's a little side note. Drop any negative signs. Okay? So what would you use on this triangle then? Tangent, inverse tangent, right? Okay. So theta prime here is going to equal the inverse tangent of the opposite side, which is 3, divided by the adjacent side, which is 2. So inverse tangent of 3 divided by 2 gets me, I get here that theta prime is 56.3099 degrees. Agree with me on that? Yeah. You gave me a look like, where did I get that from? Oh, I just typed it in my calculator. Okay, all right, with me? Okay, but that's my reference angle. remember in reference angles, we'll go green. Theta here is equal to my reference angle. Theta here is equal to 180 minus my reference angle in quadrant number 2. Theta is equal to 180 plus my reference angle in quadrant 3, and theta is equal to 360 minus my reference angle in quadrant number 4. So since I'm in quadrant number 2, my direction angle, and we label that with a theta, and then we put a little sub whatever the name of the vector is. So this would be theta sub w is going to equal here 180 degrees minus 56.3099 degrees. And I get here that theta, the direction angle of W, is 123.69 degrees. Agree? Trig-wise, that makes sense. Because if I'm over here, this is my 0 degrees, and I need to go, so then this would be 90 degrees up here. I need to go a little, it's got to be somewhere between 90 and 180. Agree? Fantastic. Okay. What I would like you to do now is I would like you to find me the magnitude of U and U's direction angle. Go. I have vector U happening down here. So that has this side as 1 and this side as the square root of 3. So the magnitude of U would be the square root of 1 squared plus negative square roots of 3 squared. That's going to be 1 plus 3, which is 4, which is the magnitude of U then is 2. So it has a length of 2 units. Agree with that part for the magnitude. Theta prime here is going to equal the inverse tangent of the square root of 3 over 1. That is this inverse tangent of the square root of 3, which is going to be 60 degrees. Okay? So my reference angle here is 60 degrees, which means my direction angle is going to be 360 degrees minus my reference angle. So the direction angle of U is going to be 300 degrees. Questions on that? Everybody got those two? Yeah? Okay. Here, on this one, we're given the fact that the magnitude of my vector is 6, so the length of the vector is 6, and the direction angle is 135 degrees. So if I draw that out, 135 degrees would be over there, which leaves me then with 45 degrees as a reference angle. I need the component form, which means that I need the y value, the vertical value of it, and the horizontal value of it, given the fact that the length here is 6. So the cosine of 45 degrees is going to be the adjacent side, ka, which is x, over 6. So x then is going to equal 6 times the cosine of 45 degrees. Anybody? 243. The sine of 45 degrees is going to be the opposite side, y, over 6. Oops. So y is going to equal 6 times the sine of 45 degrees. So y is going to be 4.243. Right? What? Because they're equal. Okay? But which quadrant am I in? I'm in the second quadrant, right? What do I know about points in quadrant number 2? The x is negative. So vector v here is going to be in component form negative 4.243, comma, positive 4.243. Now, my question to you is, we used the reference angle. Yes? And then we had to adjust it to fit the quadrant. What if we would have used the direction angle? Okay? So what if I would have done 6 times the cosine of 135 degrees? Somebody calculate that out for me quick on their calculator. 6 times the cosine of 135 degrees, excuse me. It's negative 4.243, right? Okay. What about 6 times the sine of 135 degrees? It's positive, right? Okay. So in general here, any vector v is going to equal the magnitude of v times the cosine of the direction angle of v, comma, the magnitude of v times the sine of the direction angle of v. And then you can go directly to it. You can always use reference angles, but then with reference angles, then you have to adjust to fit which quadrant you're in. This way, you don't have to. Find me those two. magnitude of V, direction angle of V. Agree that the magnitude of V is 5. Okay. V is down there with a 3 and a 4 horizontal and vertical component. So the reference angle is going to be the inverse tangent of 4 divided by 3. Remember, I dropped the negative signs on that. And if I do the inverse tangent of 4 divided by 3, I get 53.1301 degrees. Theta, my actual angle, is in quadrant 3, so that's going to be 180 plus my reference angle. So the direction angle for V is going to be 233.13 degrees. Agree with that? Okay. Now, there is something out there called a unit vector. Okay? And a unit vector is in the same direction as V, but it only has a magnitude of 1. All unit vectors have a length of 1. Okay? So to find the unit vector in the same direction as vector V, what I would do is I'm going to call this the unit vector U. That's going to be, in general, the magnitude of U. Well, U is a unit vector. What's its magnitude? 1. So this is going to be 1 times the cosine of 233.13 degrees, comma, 1 times the sine of 233.13 degrees. So my unit vector U is going to be negative 0.6, comma, negative 0.8. And if I were to find the magnitude of U, that would be negative 0.6 squared plus negative 0.8 squared, which is 3.6 plus 6.4, oops, excuse me, not 3.6, 0.36 plus 0.64, which is 1, and the square root of 1 is 1. So it's a unit vector because its length is 1. Okay? We have special unit vectors out there. Okay? We have 2 of them actually. we have I, which is the unit vector 1, 0. And we have the unit vector j, which is 0, 1. So we have two special unit vectors that allow us to express any vector in a form known in math circles as a vector written as a linear combination of I and j. And I can write any vector using the i's and j's. Okay. So the vector v, -3, -4, that vector that we just did, written as, if I wrote this out as -3 times the vector 1, 0, and added it to -4 times that vector, that would give me the vector here of, oops, let me expand this up, -3, 0 plus 0, -4, which if I add those two vectors together from last night, we get that. Okay. So if I go off of this line here, then this is -3i minus 4j. Okay. So we can write any vector. So if we go back, if you flip your packet over a page, so if we go back to like number 4, in number 4, vector u was -2 and 5, right? Written in I and j form, that would be -2i plus 5j. Vector v in number 5 would be what in I and j form? So 3i minus 2j. Okay? Okay? Very easy, very quick. That's really the amount of time that we need to spend on that. Okay? So you should have a big box now on the bottom of your page that says, in general, if vector v is of the components x and y, that would be a linear combination xi plus yj. X, then, is going to equal the magnitude of v times the cosine of v's direction angle. Y is going to be the magnitude of v times the sine of v's direction angle. The magnitude of v is going to be the square root of x squared plus y squared. Again, this is all stuff that we've been doing for the last half hour. Okay. And the reference angle is going to be the inverse tangent of y divided by x, with the one caveat, excuse me, is that we drop any negative SIGN signs. I don't know why it won't let me put the S on signs. Probably because I was right on top of that thingy-mabobby. Okay. That is crucial. Okay, that box that you just filled in, that's everything that you need to know in regards to vectors. Okay? So, magnitude of u is 2. Direction angle of u is 30 degrees. Magnitude of v is 3. Direction angle of v is 90 degrees. We want you to find u plus v in component form, the magnitude of u plus v, and u plus v's direction angle. Okay? Well, if I were tackling this problem and I saw here u plus v, I see that, I probably want to know what vector u is and what vector v is. Okay? So let's find them. Vector u is going to be what? What is the component form of vector u? The magnitude mark is 2, but that's not the component form. What would the component form be? Or, we'll take it even a step back. How would I go about finding the component form? Sure. No. I get that it's 30, 60, 90 triangle, but there's no triangle here because it's a vector. You literally just wrote it down.
Times cosine of 30.
So what? I missed the first part. I'm sorry.
2 times the cosine of 30.
2 times the cosine of 30. And 2 times the sine of 30. Figure those out for me. Let me ask. I hear you typing stuff on calculators, but do we need to type on calculators for this one? Right? What's the cosine of 30? What's the cosine of 30? Say louder. Square root of 3 over 2, right? And I got to multiply that by 2. So what's the square root of 3 over 2 times 2? Just the square root of 3. What's the sine at 30 degrees? 1/2 times 2. 1. Now, my question to you is this. Why did I go that route instead of going on a calculator? Because if I use the calculator, I'm going to do what? I'm going to get a decimal number. And I'm going to have to use those numbers later on, right? So if we can be exact as long as you possibly can. Until it comes a point in time when you can't be exact anymore. But you want to be as exact as you possibly can for as long as you possibly can. Okay? So there's vector u. Now I need vector v. What is the component form of vector v? or take it a step back. How do I find the component form of vector v? Somebody was whispering, yeah?
We got it.
Three cosine 90. What you got? 0. 3 sine 90. 3. Okay. So now I want the vector u plus v in component form. Square root of 3 comma 4, because I add up these two x's, and add up those two y's, right? So that's going to be the square root of 3 comma 4. Of course it wouldn't. Well, fine then. Let's go like this. Yes, Now, I want to find the magnitude of that one. So that's going to be the square root of 3 quantity squared plus 4 quantity squared, and I'm going to take the square root of that. Square root of 3 squared. 3. 4 squared. No, it's the greatest kids game ever. Did you ever play 4 squared before? Wow. Wow. What?
I'm the best person to ever play 4 square.
Don't make me start moving desks around, Paul.
Let's do it.
I will wail on you.
Let's do that instead of the test.
What?
Let's
Okay,
do that instead of the
Next
test.
Wednesday.
We need a ball, though.
Robin turn.
We need a ball.
I'll bring a ball.
Okay, bring a ball. All right? So the magnitude of u plus v is going to be the square root of 19. Now we got to find the direction angle of u plus v. So my reference angle is going to be the inverse tangent of 4 divided by the square root of 3. Yes? Which quadrant is vector u plus v in? It's in 1. So my reference angle is my direction angle because we're in quadrant number 1. Oops, excuse me, I should write this in proper notation. Okay. Now, it's number 10 on your worksheet. We don't have enough time to do it right now, but it's probably going to be collected at some point in the next week. Number 10. Okay? All right? forget that you have an online formative that you have to do in the next couple of days. So what would that be? 1, 2, 3. In the next 4 days, you've got an online formative that you have to do. I want to spend the last remaining time here, the last 5 minutes. I want to hand stuff back because we got a ton of stuff to hand back. So, okay.